In this video, I will show you how to create a viral title and thumbnail generator in n8n. The idea of this workflow is when you have a content idea, you come here in input and you enter your content idea. Then the workflow will proceed and return you a list of titles as you can see here, and also a thumbnail that we'll review just here. All of this is based on performing videos for your content idea. Now let's review each node to see how this is working. So let's begin with the input. So we have a classic trigger here, and the example for this test is boil eggs perfectly. So you go on content idea here, and the query is perfectly boiled eggs. So as I said at the beginning, this is where you will come and enter your content idea. After this, we'll try to create a data set of videos that are on this content idea. So this will be in two steps. The first one will be with this node to create some keyword based on the content idea, and then scrap videos based on these keywords, thanks to API. So let's review this node. You are a YouTube content strategist, and the input of the request is the following content idea, and you enter your query here. You require a specific output format because we want to have the output as 3 keywords that we'll use later. So the message type is text, and you enter your message just below. So you give the instruction you want. Here for this case, I wanted to have, as you can see here, 3 keywords from 1 to 5 words each that are highly relevant for YouTube search, based on what people would realistically search for, focused on action techniques or tools, not just literal parts of the content idea, and avoid abstract terms that would not return good search results. And you can give some example under it. As you can see on the right side, we have the output as 3 keywords, name keyword 1, 2, and 3. How to boil eggs perfectly, perfect egg boiling technique, boil eggs step by step, etc. As I said, we have a structured output parser. So because we enabled it here, you will have the possibility to add one under output parser here. And we just enter a JSON with each variable, so keyword 1, 2, and 3, and the type that is a string. After this, we have a wait node that I like to add after a generative LLM. So we just wait, I think this is 5 seconds. And this is where we will scrap videos from YouTube search based on the 3 keywords we've created, and thanks to API. So let me open this node. So we're using YouTube Scrapper from Streamers. This is where you will have the option on how to use the scrapper. So you can select the maximum video per search term for shorts, for stream. You can use some direct URLs, but we're not using them for this video. You can also scrap subtitles if you want, but this is not required. You can add some filters, so relevance, this week, lens filter, HD, 4K, etc. You can have a date range, only applicable if you're scrapping by channel URL, and some run option that we'll not use. But if you come on the top here, you will see that you have a JSON option that we'll use in the HTTP request node. So you come on JSON, will not use a lot of this. You copy all of this, and you can go back on n8n. You go on send body content type JSON, using JSON, and you paste your request. For this workflow, we just need some parameters. So you can open it. You keep only the date filter that you put on yearly. So you can put month, day, etc. But here is the best in my opinion. The length filter is between 420. So this is the classic format of YouTube videos. The max results will be the number of videos that are scrapped per keyword. So if you have 3 keywords, this will be 21. The more you increase the max results, the better your final output will be, but it will also cost more. So you have to find your sweet spot. The search query is, so this is the list of keywords, so keyword 1, 2, and 3 that you can take from the previous nodes. And the sorting order is relevant because you want the more relevant video at the beginning. So once you have this, you can go back on API, you go on API endpoint, and this is where we'll find all the information to set up our HTTP request node. So for this node, we're trying only to run the actor. So we'll use the first request. As you can see here at the end of each request, you have your token that is hidden. But if you copy it, it will be included when you paste it. So you copy the first request because we want to run the actor. And this is a post request. So you go back here, the method is post, and you paste your URL here. There is no authentication because you already have your token in your URL. No need to send any parameters. You send a header using the field below, content type, application/JSON, and we already configured the body just before. So you can go back on the workflow and let's move on the next step. Here we will just use a simple loop to check if the dataset is completed on AP5 because it takes some seconds to be completed. So we'll use another request that is called which one is it? It's get the last run. So this is a get request. Again, you copy the link, you create another HTTP request, you open it. So this is a get method. You paste your new URL. And normally on the right side, as you can see, you will have status running or completed. So this is the element that we'll check at the beginning of every loop. So after checking, you go on an if node, and if the status here is equal to succeeded, you can go on the next step. If it's not, you go on the false pass and you wait. You can set up 5 to 10 seconds and you just try again and again until it's succeeded. After this verification step, this is where we'll filter performing videos. So the first step here is to get the data, so to get the data set from AP5. So to do this, you go again on API and we used get last run. And now we want to use get last run dataset item. So you come here, you copy the URL. This is a get method. You create an HTTP request node, get, and you paste your URL. As you can see on the right side, we have all the information for each video. So we have the title, the URL, the thumbnail URL, view count, likes, channel name, channel URL, etc., etc. But now, if we want to keep only the performing videos, we need to have a data, an indicator that will help us to rank these videos. So this is why here we'll try to calculate the CTR of a video. So for those who don't know, this is the click-through rate percentage. So when someone see your video, how many people click on this video in percentage. But the thing is, this is not a value that is available publicly. You can have it on your YouTube Studio dashboard. But for video of other people, you need to have a way to calculate this. So this is where we'll try to create an approximation of the CTR that we'll see just here. So the idea of this node, that is a co-node, by the way, in JavaScript, is to use data that we just scrapped and create something that is working like the CTR. So we create multiple constants that we'll use later. So we have the views, the subscribers, the likes, the comments, and the publish date. So first we have an if loop to check if one of these values, so view, subscriber, and publish at is null, and return an error in case data is missing. Then we create two new values that are publish date and now. So we have the date and time of when the video was posted and the date and time of now. We do a small verification here on the date value. And this is where we'll start the calculation. So we'll try to calculate the time between the publish date and now. So we convert everything in millisecond. So you calculate the number of milliseconds per day, you calculate the time difference, and you calculate the days since upload. After this, we'll calculate the RPI, that is an approximation of the CTR. We don't take in consideration time here, we'll add it just after. So this is view divided by subscriber, multiplied by like plus comment divided by view divided by 10. These are not formulas that I created out of nowhere. I just found them online and I just converted them into code. So if you're not happy with these formulas, you can tweak them if you want. After this, we'll add a decay factor. So to explain the decay factor, let's imagine that you have a creator that have posted a video 1 day ago and 1 year ago. If the video of 1 year ago has 10,000 views, it doesn't mean that this video was highly performing, but just over time, YouTube recommended this video. But if the video was posted 1 day before and had also 10,000 views, this have way more impact. So this is why we're using a decay factor. So you have this formula with the day since upload inside of it. And at the end, to adjust the RPI, you just have to add a decay factor. And if you want to convert this RPI adjusted to a pseudo CTR, you just multiply it by 100 to have the value as a percentage. And you return the value as a float, so a number with a comma or a point, and three numbers here after the comma maximum. So as you can see on the right side, we have the value of this formula. We'll just merge the value of the API scrapper and the CTR scores. Just a small note on the code node, make sure to run once for each item and not once for all item. And for the merge node, you just select combine by position, and the number of input is obviously 2. After this, you add a filter node. So this is where we'll filter all of this video per CTR. So you just open it. You add the JSON CTR percent that you find in the merge data node. And if it's greater than, so for me, I found it that the value 0.1 is a great value to find performing videos, but you can change it if you want really high performing videos, or if you can tolerate less performing videos in your list. So you have to choose which value is better for you. But be careful, because if you decrease this, you will have way more videos that are coming in, so that are kept. And if you increase it, you will have way more value that are discarded. So you have to find the sweet spot again. And as you can see here, we had 21 items entering this node, and only 4 that we'll use to create our titles and thumbnail. The thing is, for testing, 4 items is okay, but if you want to use it in for a real use case, I would recommend you to have at least 10 to 15 value that are exiting this node. So you have two options for this. Either you scrap more videos here per keyword, so you increase this value here, or you decrease the filter here, or you can do obviously both. After this, we'll go to the generation step. So we'll first generate titles and then thumbnail. So the first step for generating titles is to create a list of titles that we scrapped of performing videos. So as you can see on the right side, because we only have 4 items, we have a list of 4 items. After this, we'll use a basic LLM chain that will take in input this title of performing videos, analyze pattern on these titles, and create a prompt based on these patterns. So let me open it. So you are an expert in YouTube video title optimization. Here is your input. So you add the list of titles of performing videos. And so you add a message. And this is where you can create your own prompt if you want, or reuse this one. So you add the initial query at the beginning. That was perfectly boiled eggs. You give him some tasks to do. So first, analyze the title for patterns such as repeating structures, use of numbers, brackets, capital letters, etc., word combination, or topic angles, etc. Then you summarize what makes this title effective in 5 to 15 points. And based on your analysis, generate a prompt for another AI model. This prompt will instruct the second model to generate new YouTube titles for the same keyword topic, etc., etc. After this, you have some more indication that you can read, but basically you have the format of the prompt, some example of input, example of output, and example of prompt that is created. So after this, we do like we did just before. We add a weight node after a generative LLM, and we add another basic LLM chain where we will create these titles. So here again, you are an expert in YouTube video title optimization, and the message is just the output of the previous basic LLM chain. And as you can see here, the output was pattern summary. So the list of patterns observed in high performing video titles for your initial query. And after this, you have the prompt. And just make sure to require a specific output format, because we want just the title as output. So you have title 1, 2, 3, 4, 5. Once you have this, let's generate the thumbnail. So we use a loop over item. So we loop over the 4 elements here. we'll use an analyze image node from OpenAI. You have two options for it. You can use the API from OpenAI or the API from OpenRouter. You will just have to change your base URL here to OpenRouter AI API v1. The resource is an image, operation analyze image. You can select the model you prefer, but if you want a free version, you can use this one. So Llama Vision Instruct free. The text input is you are an expert in YouTube thumbnail performance. Your job is to analyze why a thumbnail might be performing well and describe it so a designer or AI can later recreate its essence. So you have the subject of the video from the initial query and the URL of the thumbnail image that you take from the loop over item node here. And your goal is to analyze the thumbnail visual elements, identify what make it visually compelling or attention grabbing, relate your analysis back to the video subject, and return a structured and precise description of the thumbnail that could be reused to generate a similar performing image. Respond only with description, do not add anything else. So the input type is image URL and you add the URL again here. And as you can see, if we go on the output, we have the description of the thumbnail. Then you wait again because we use generative AI and you do this for each element from the top performing videos. After this, when this is done and all elements are treated, you add a code node that we'll use to create a list of analysis. So as you can see, we just create a list here and we return it. So as you can see, we have 0, 1, 2, 3. So for the four elements. And after this, we'll use a basic LLM node to create a prompt as we did just here. So let me open this. So you are an expert visual prompt engineer. I added some instruction that you can modify. So you are given several thumbnail analysis texts, each describing what made a YouTube thumbnail visually engaging and effective. Data for you, you add the initial query and after this, the list of analysis. And your job is to summarize the most common and impactful visual element across all analysis and generate one precise image prompt that captures the best performing element ready to be used with an image generation tools. Mandatory maximum 400 characters because this is for the maximum token limit. And when generating the prompt text, make sure that any double quote within the string are using a backslash because sometimes in the prompt we'll use some quotation note like this and this will cause to throw an error. So you have to specify this. So the input is a list of thumbnail description and visual analysis. The goal, one image prompt that include clear guidance on subject placement or expression, color and contrast, textile or layout if any, graphic or visual elements, overall layout or composition, mood or tone, etc. Don't describe what you are doing, just output the final image prompt and you give an example under it. So after this, we'll use an HTTP request node to make a request to Hugging Face that we'll use to generate this image. So we use this model that I find really efficient. That is Black Forest Labs Flux One Dev. So Flux One is really good to generate image for thumbnails, in my opinion. So you open this node and you make a post request. You copy the list of the requests for this model. So this is API inference, huggingface.com, models, Black Forest Lab, Flux One Dev. No authentication because we'll specify it in the header. So using fields below, authorization, so you add bearer and your API key just after. Make sure when you create your API key in Hugging Face that you select the read option. Second parameters is accept. We want as an output an image slash PNG. So this is the output we want. As you can see here, this is a PNG. And the name of the last header parameter is content type application slash JSON. After this, you send a body, so in a JSON form, and you specify these parameters. So you have the input that is the prompt created just before that you take from create prompt node. The parameter are the one for a YouTube thumbnail. So height 720, width 1280. After this, you have NEM inference steps and guidance scale. So for these two parameters, I found it that 30 and 8 were good values, but you can play with it to see what type of thumbnail you prefer. And as you can see on the right side, we have the thumbnail created. It's high quality. You have the idea that the egg is the center of the thumbnail. You don't have too much element around, too much text. You don't have text at all for this thumbnail. So this is a pretty good thumbnail. So after this is where you will do whatever you want with these values. You can directly upload it on YouTube. You can upload it on the database, on the Google Drive, etc. I choose to have it just as an HTML page that I can send, for example, via email. So you can do whatever you like. I will just show you how I did it for the HTML template. So if you want to have it as an HTML template, you cannot use directly the PNG image. You have to convert it in base64. So you use this node, move file to base64 string, input binary field data, destination output field data, and file encoding base64. So basically it will convert your image into a string, so text. And I forgot to show you this in the HTML, in the HTTP request node. On the bottom, you can add an option. So the response is a file that is called data. So it's easier to use it after. So once you have this, you just merge everything. So you append the two inputs. So you have the titles and the data. And you just paste everything in an HTML page. So you add the H1 that is a thumbnail. You add the image here, as you can see, with the base64 string at the end here. And you add the titles. You just drag them from here, 1, 2, 3, and you add a back to line like this. And you can have, and you click on show data, the titles here, and normally you should have the thumbnail, but because I executed this node after executed everything else, I don't have it. But if you execute the whole workflow, you will have it. So in my opinion, the output titles and thumbnail are pretty accurate and relevant. You are not obligated, of course, to use it directly like this, but you can at least use them as ideas. I wanted to make a test to see what it would look like on YouTube if we're using the thumbnail generated and the first title here. I don't know what you think about this, but in my opinion, this is a pretty good title and thumbnail that you could use directly on YouTube. But if you don't like this result, you can obviously do some modification and don't use this packaging directly. And again, you can find this template for free in description. You just have to download the JSON file and come here, import from file, and you just have to set up some API keys, and you can use directly this for your own content ideas. So I hope this video will help you to create your title and thumbnail faster. Let me know in the comments if you have any question regarding this. Thank you for watching.